The development of photovoltaic PV technology, or solar cell technology, began during the Industrial Revolution. In 1839, French physicist Alexander Edmond Becquerel first demonstrated the ability of solar cells to convert sunlight into electricity, known as the photovoltaic effect. In 1883, American inventor Charles Fritts created the world's first rooftop solar array in New York. Einstein wrote a paper explaining the photoelectric effect in 1905, which explained how the selenium coating on the solar arrays caused a weak electric current. The research done by Einstein and Becquerel was the start of further developments in PV technology, and also won Einstein a Nobel Prize in 1921. In 1954, a modern PV cell was created by Bell Labs. However, the use of them for energy was too expensive for commercial use. Instead, in the 1950s, the U.S. military funded research for PV technology to power satellites. The first spacecraft to use solar panels, Vanguard 1, was launched by the U.S. Naval Research Lab in 1958. In 1964, the first satellite with panels that tracked the sun, Nimbus 1, was launched by NASA. In order to improve solar energy technology so it could be used to heat and cool government-owned buildings, Congress passed the Solar Energy Research, Development, and Demonstration Act in 1974. The goal was to create the Solar Energy Coordination and Management Project directly targeting the Department of Housing and Urban Development, the National Science Foundation, and NASA. In 1974, the Energy Research and Development Administration, ERDA, was created in order to report on the development of the agency's solar program directly to Congress and the President. Later, in 1978, the Public Utility Regulatory Policies Act was passed by Congress to lay the grounds for net metering policies and distribution of solar energy. The Solar Photovoltaic Energy Research, Development, and Demonstration Act was passed in 1978 to organize a strategy for the international marketing of solar cell technology. To this day, the government continues to subsidize the research, commercialization, and regulation of the solar energy industry.
Solar cells rely on semiconductive material to transform light energy into usable electrical energy. One of the most abundant elements in the Earth's crust also happens to be one of the best semiconductors. Crystalline silicon can act as a semiconductive material, meaning that when mixed with an insulator, it becomes a storage bank for electrons. When light hits a unit of crystalline silicon, the photons of light will transfer their energy to nearby electrons, which then travel through the material as electricity. The secret to silicon's ability as a semiconductor lies within its molecular geometry. Individual silicon atoms tend to bind together to form a crystalline silicon lattice, and it's because of this organized structure that silicon can effectively transform light energy into electrical energy. Today, silicon destined for solar cells is made by heating sand with carbon at temperatures upwards of 4,000 degrees Fahrenheit, where it is then inlaid in a glass, metal, or plastic panel. It is this panel that we call a solar cell. A solar cell can last upwards of 25 years, still producing more than 80% of its original power. The widespread use of solar panels can indirectly stimulate the economy by encouraging people to spend their hard-earned money on leisure products and activities instead of the electricity bill. Also, solar panels are great for the environment. Silicon's versatility as a substance can be credited to its molecular structure and thus is common in most modern technology. Silicon is used in rectifiers, an electrical device that converts an alternating current into a direct current by forcing it to flow in one direction. It is also used as a conductor in computer motherboards. As mentioned before, silicon is a versatile molecule and has anti-corrosive properties, which is why it is also used as an anti-rust resin in all mechanic shops. Various forms of silicone are also used in the production of soap, smoke grenades, and adhesive.